Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 21st, 2025, just yesterday. This paper's new model outperforms a state-of-the-art system by over 9% on a key benchmark, while using 10 times fewer parameters. The paper is titled GUI-G Square, Gaussian Reward Modeling for GUI Grounding, and it introduces a really clever way to think about how AIs interact with interfaces. So it tackles a key problem in training AIs for graphical interfaces, using a reward system inspired by human clicking patterns. Also, the authors shared their work on GitHub, and it's quite complete. If you check it out, you'll find all the source code, installation instructions, and training scripts. They even provide guidance on how to customize the reward model for your own projects, which is a really nice touch. Alright, so this first figure really sets the stage for a task called GUI grounding, which is teaching an AI to find the right spot on a screen from a command like click the send button. On the right, we see why their new reward system makes so much sense. This chart shows how humans actually click. It's a spread that looks like a bell curve, or what's called a Gaussian distribution. Most clicks land near the target's center. Based on that idea, the chart on the left plots performance. Their new model, GUI-G Square, is at the very top with a crown, scoring highest on the Screen Spot Pro benchmark, while being much smaller than its competitors. This visual really shows the power of their approach. Building on that insight about human clicks, this figure really breaks down why their method works so well. It compares different reward modeling strategies, which are ways of giving the AI feedback. The first few panels show older methods. They often use what's called a sparse reward, basically a simple hit-or-miss signal, which isn't very helpful if the AI is just a little bit off. But on the right, we see their new Gaussian approach. It creates a rich, continuous reward with two parts, a point reward for precision and a coverage reward for matching the target size. This much more informative feedback helps the model learn faster and more effectively. This diagram then lays out the entire architecture. At the top, we see the AI agent, or policy model, which takes a command and generates several possible answers. Then, the reward model kicks in. The bottom section visualizes those two rewards we discussed, the Gaussian point reward for precision, which looks like a sharp peak, and the Gaussian coverage reward, which measures the overlap in shape and size. This combined feedback then guides the learning process using a method called Group Relative Policy Optimization, or GRPO, a technique that helps the model learn effectively from multiple guesses at once. Moving to the results, this table provides the hard numbers. It compares the older sparse reward methods, which are simple hit-or-miss signals, with their new dense reward system. The top section shows scores for sparse methods, like a basic point reward, or using intersection over union, which just measures simple overlap. Their average scores hover in the mid-80s. But the bottom row shows GUI-G Square, using its dense Gaussian rewards, consistently outperforming them across mobile, desktop, and web interfaces. Its final average of 93.3% is a huge leap, proving this more detailed feedback really works. And this next table provides an even broader competitive landscape. It pits GUI-G Square against a whole range of other models on the ScreenSpot benchmark, everything from proprietary models like GPT-4o to other specialized models. These are grouped by their training method, like supervised fine-tuning, which is a common way to specialize a model, or reinforcement learning. And right at the bottom, we see GUI-G Square. It consistently achieves the best results across the board, highlighted in bold, with a final average of 93.3%. This performance is especially impressive, as it beats even much larger models. Now, to really push the model, this table shows its performance on an even more challenging benchmark called ScreenSpot Pro. This benchmark tests the model across a wide variety of professional software, from CAD and developer tools to creative and office applications. And once again, GUI-G Square, shown at the very bottom, comes out on top. It scores an average of 47.5%, which is a nearly 10% jump over the previous best model, UI-TARS 72B, a model that is 10 times larger. This really highlights the efficiency and power of their Gaussian reward approach. So to wrap things up, the key takeaway from this paper is truly profound. By moving away from simple hit-or-miss feedback and instead using a rich, continuous Gaussian reward system, the model learns much more effectively. This new approach, which more closely mirrors how humans actually interact with screens, allowed a much smaller model to vastly outperform competitors 10 times its size. And interestingly, the authors found that for this kind of task, locating things on a screen, explicit step-by-step reasoning actually hurt performance. That's all for today's AI Research Roundup. Thanks for tuning in.